A mini-zine I made on the 4 phases of mitosis. Interphase. Before mitosis, there's a period of time when the cell grows. Interphase is split into 3 sections: G1, S, and G2. The phase shown on the left is G2. In G1, gap 1, the cell grows in size and synthesizes proteins. This is the phase where the cell does its normal cell things. If a cell isn't going to divide again, it will enter a G0 phase. In the S, or synthesis phase, the cell copies its DNA so that when it is ready to divide, both cells will have all the same DNA. And finally, G2. In G2, the cell continues growing and ensures that the cell is ready to divide. Once the phase is complete, mitosis can begin. Prophase. Prophase is the first phase of mitosis. Before prophase, the DNA was in the form of chromatin, which is all jumbled up and disordered. But during prophase, the DNA starts to get organized into chromatids. The chromatids come in linked pairs called sister chromatids, which contain the same genetic information, as they were duplicated during interphase. Inside the nucleus, there's an organelle called the nucleolus, which produces ribosomes. During prophase, the nucleolus breaks down. Because of this, ribosome production can't continue until the nucleolus reforms again in interphase. Also during prophase, the centrosomes move to the opposite poles, and the mitotic spindle begins to form. Prometaphase. By the start of prometaphase, the chromosomes are fully formed. During the phase, the nuclear envelope disintegrates so the chromosomes can attach to the microtubules to be pulled apart. In prometaphase, microtubules are grown from the centrosomes. Some of the microtubules attach to the microtubules from the opposite centrosome. Others find the kinetochores on the center of the chromosomes. Kinetochores are small disc-shaped proteins that are formed on the chromosomes in late prophase. Metaphase. By the end of prometaphase, all chromosomes have been connected to centromeres by kinetochore microtubules. Metaphase is when a cell really begins to start dividing into 2 separate cells. In metaphase, the centrosomes start pulling on the chromosomes and aligning them along the metaphase plate. The metaphase plate is an imaginary line between the 2 centrosomes, approximately in the middle of the cell. Anaphase. During anaphase, the chromosomes are separated into their daughter chromatids by the outward force of the centrosomes. Since each pair of chromatids in a chromosome contain the same genetic information, each cell gets 1 copy of the cell's DNA. Anaphase is split into 2 phases, anaphase A and anaphase B. In anaphase A, the kinetochore microtubule that attaches the chromosome to the centrosome is shortened and pulls the chromosomes towards the opposite poles. Since the kinetochore oh my gosh, I did not do spell check on this. Since the kinetochore microtubules of opposite poles attached to the pairs of chromatids, the chromosomes are pulled apart into their daughter chromatids. Anaphase B is quite interesting. Not all microtubules attach to the kinetochores on the chromosomes. Some are interpolar microtubules that join the centrosomes at opposite poles to each other. As they grow, they push against each other, which pushes the centrosomes further apart. Some microtubules are astral microtubules, which start at a centrosome and end at the cell membrane close to the pole they sit at. These astral microtubules ensure that they stay close to the cell membrane on their side as the cell enters into telophase. Telophase. During telophase, the cell continues elongating by the interpolar microtubules getting longer. The further the centrosomes get from each other, the more the cell separates into 2. The nucleus also begins to reform. The nuclear envelope is rebuilt from the vesicles that were left when it disintegrated. The chromosomes also unfold back into chromatin to continue to be used in interphase. Chromosomes are rather densely packed, and it would be rather impractical for a cell to have all its DNA always packed together into chromosomes, so it unfolds into chromatin, which is much easier for a cell to deal with. Chromatin isn't entirely loose, though. It isn't just the DNA in 26 strands, as those would get tangled really quickly. Chromatin is wrapped around proteins called histones, which make sure that DNA doesn't get too tangled. They turn into chromosomes again next time the cell wants to divide. Cytokinesis. Cytokinesis isn't a phase of mitosis, but a process necessary for it. In cytokinesis, a pinch forms in the place where the metaphase plate was, and pinches apart the two cells and their nuclei. And that's cell division. I hope you enjoyed reading this as much as I enjoyed writing it. 1:43 a.m.